Hello, everyone. I hope I'm audible. I hope, can you give me a quick confirmation whether I'm audible or not? Hey, guys, can you give me a quick confirmation if I'm audible or not? Hi, good evening, everybody. Amazing, amazing. Okay, I can see many faces. Okay, I can. I hope everybody, like, it's clearly audible right now, whatever I'm talking. Yeah, so perfect. Yeah, after many days, finally, I got time to start the community session, and probably every month we'll plan it, like a couple of community sessions we'll try to plan. So I hope everybody likes the new setup that I have actually done. Yeah. No, this is a separate community session, guys. So hit like if you are new to this channel. Make sure that you subscribe the channel and yes, share with all your friends. As said, because we are starting this community session, it will be there for 5 days. So today, the day one of deep learning will be starting. Just a small request, everyone. See, all the videos, materials, and all will be put up in the course link that is given in the description. Please go ahead and enroll it. It is completely for free, so you can directly go and check out the link in the description. Please give me a confirmation once you enroll it over there, because all the materials, everything, all the videos will be put up over there along with my YouTube channel. The materials are very much important, so many people had requested for that specific thing. So what did I do is that I made a separate course which is called as a community course in iNeuron dashboard, so that you will be able to access it for lifetime, right? So please give a confirmation if you're able to see the link in the description of this particular video, and please go ahead. Okay. And we will just be starting in another 2 minutes, since I have already told that we'll be starting the session at 7 p.m. IST sharp. So a request, everybody, till then, quickly enroll for the course link that is given in the description. Okay. And just give me a confirmation. And yes, just go over there in the description. It is a new page community session that you will probably be able to see. Enroll it over there, create an account so that you'll be able to see this. Okay. Yeah, I'll also try to cover some part of NLP. Okay, perfect. So another 1 minute. Till then, I'll be taking up any kind of questions that you have. We will be having a lot of discussions today, and probably we'll be starting deep learning from basics. This complete 5 days, we will try to cover so many topics that are there. Yeah, do we get a certificate? Yes, you can also get a certificate from it, from the 5 days session that you already have. Okay. So let me share my screen, and here you go. So I hope everybody is able to see my screen. Can I give a quick confirmation? Yeah. So as usual, what all things we will be discussing today. So day one of deep learning, we are going to cover completely from basics, and it will definitely be helpful for your interviews and the other things that you really want. Because definitely whatever I'm teaching, those kind of questions are usually asked in an interview, and everybody can follow this, and probably I'll also be asking a lot of questions. So hit like before we go ahead, share this link with all of your friends, whoever wants to join, and we will probably start in a couple of minutes. Okay. So this is the day one of deep learning. The motive is to make people clear the basics. Here I will be covering maths and definitely interview preparation part, right? Interview preparation part will be covered if you are looking for becoming a deep learning developer, or you are planning to move into the computer vision. So everything will be actually be able to cover it over here. So what are things we are going to cover today? So the agenda, as usual, we start with the agenda. So the agenda of the session, number one, we will be understanding about deep learning. So entire deep learning things. Okay. Now we will start with something called as Perceptron. And before that, we will also be understanding what is the difference between AI versus ML versus DL versus data science. Okay, since this is the introduction session. The timing of this session is between 7 p.m. to 9 p.m. IST. Please make sure that you enroll in the below link that is given in the description of this particular video. Okay, so that I put up all the materials that I'm writing in front of you over there. So we'll also be understanding what is a brief idea about forward propagation and backward propagation. So we will also be covering forward propagation and backward propagation. The fourth point that we are probably going to cover is that, not in today's class, but a brief idea about loss function. Fifth one is something called as activation functions. Okay. Sixth one that we are going to basically see is something called as optimizers. Okay. So we are trying to cover all these things, and we'll try to cover up. See, in the 1,000, like if you are in the 1,000 feet height, right? What is exactly deep learning? Why are these terms coming up? All those things we'll try to discuss. Tomorrow, projects will also be covered on the second or the third day. We'll try to cover projects, and we will be learning in such a way that we understand the maths, we understand it properly, we do the implementation, and at the end of the day, it will be helpful for the interview preparation. So I think most of the people have joined. We can probably start in a minute. Okay. So yes, I hope everybody's ready. The energy is high. So hit like, we will be starting the session, right? Prerequisite, some idea about machine learning. So your prerequisite is that you need to know Python programming language. Prerequisite, you need to know number one, Python. Some idea about at least one algorithm in machine learning. And third is that some idea about stats, which I have already taken in the previous session. Okay. So we will try to cover only this. Yes, if linear regression also, that is more than sufficient to start with. Okay. So let's go ahead and let's start the first thing. The first topic of this session, we are going to cover something called as AI versus ML versus DL versus data science, right? And what is the importance of DL? We will be trying to know, and deep learning. This will be our main focus of this session, where we will be understanding about deep learning. Okay. So this is what we are basically going to cover up. Okay. So perfect. Let's go ahead and let's start. Okay. Let's consider this entire universe. Let's consider there is a universe which is called as AI. Okay. So suppose if I say this is the universe of AI. This is a separate universe. Let's say consider it AI. And I hope everybody knows the full form of AI, that is artificial intelligence. So here we try to create an application. So AI is a kind of application which can do its own task. It can do its own task without any human intervention. Without any human intervention. Okay. So this is what is exactly AI. Okay, without any human intervention. So human intervention basically means that the human do not have to tell the application what to do. Just with the behavior of the user, of the person that who is using this application, it can automatically take its own decision. Best example that I would like to consider, number one, I hope everybody has seen Netflix app. It provides you automatic recommendation. Second is self-driving cars, autopilot cars, self-driving cars. I think you have a brief idea about it. Third, let's say Amazon application. So Amazon application, which wherever you do the shopping, right? Automatic recommendations are there. If I talk about AI application, it is just like an AI module integrated with integrated with the software that is already existing. Like Netflix app is obviously used for seeing movies, okay? But to make the experience better, what we do is that we include an AI model which gives you recommendation based on your behavior, right? So all these things we actually cover in this specific thing. At the end of the day, whether you are working as a computer vision developer, you are working as a data scientist, you are working as a deep learning developer, at the end of the day, you are actually creating an AI application. That is the most important thing to understand. Okay. Yes, very good example. Probably you have seen Sophia, you have seen chatbots, right? Chatbots is one of the tasks which we specifically do, right? So chatbot is also one of the tasks, one of the AI application in short, you can basically consider. And I hope everybody knows recently, Elon Musk, he's bought Twitter for $44.2 billion. And three main reasons what he has actually given is that one of the most important reason that is definitely helpful for all the people who are learning AI. So he wants to make the machine learning algorithm that is basically used to recommend the content as an open source. Okay. Now, if this is coming as an open source, trust me, it will be quite amazing, because then you'll be able to get the idea. Yes, a kind of recommendation idea we already have. But if that entire machine learning algorithm is made as an open source, you will definitely be able to understand how does YouTube recommendation work or Instagram recommendation works, and different kind of recommendation actually work. Okay. So this is what actually comes in the form of AI. So here AI is nothing but artificial intelligence. Now let's go to the next one, which is called as machine learning. So machine learning is a subset of AI. So suppose if I probably draw a kind of circle over here, and this circle is quite big. Suppose let's say I am drawing a circle. Again, it is a little bit big. It's okay. Let's say this is machine learning. Okay. Now in this machine learning, what happens is that suppose if I consider this is machine learning. Okay. So in machine learning, what exactly is machine learning, and what do we do in machine learning? Okay. So machine learning basically provides you stats tool to analyze the data, visualize the data, and to do most of the machine learning tasks like predictions, forecasting, and many more things, right? And similarly, in unsupervised, we do clustering, forecasting, and many more things, right? So this is what a machine learning is all about. They provide you stats tool, to analyze the data, visualize the data, predictions, doing forecasting, and clustering. Yeah, Power BI is also kind of tool which will actually help you to analyze the data and all, right? So internally, it also uses a machine learning application, machine learning algorithms over there. It uses visualization tools integrated into it. But at the end of the day, again, it is a kind of an AI application itself, right? So here, I hope everybody has got an idea about what exactly machine learning is all about, So it provides you stats tool. If you really want to make any person understand, you have to basically say in this particular way that it provides stats tool to analyze the data, visualize the data, predictions, doing forecasting and clustering and all, right? So anyhow, we basically say machine learning, ML, is a subset of AI. Okay. ML is a subset of AI. Perfect. So I hope everybody has understood till here. I hope you're getting that better definition, what you are basically learning in these things, right? Now, coming to this, now it's not like machine learning, machine learning, whenever we talk about, there are different components also that comes, like NLP, natural language processing. Over there, it will be an integrated part of it. Suppose if you use tools like programming language like Python. We use stats, to understand different things. But here I'm trying to cover the major chunk, which will basically help you to understand all these things. Now coming to the next one, which is called as deep learning. Now deep learning, super important. Okay, and this is what our entire 5 session is all about. So another subset of machine learning, we basically say it as deep learning. Okay, deep learning is not becoming is it's not like recently only did not come up. Deep learning, the researcher were, if I probably write it over here, the researchers were working from 1958. Researchers were basically working from 1958, but right now it became really amazing because of the amount of data that is getting created, and because of amazing GPU hardwares that we have, thanks to Nvidia, because of that entire research that they are actually doing. Right now I'm also having RTX 3090, and probably if you work with this GPU, trust me, how amazing models you will be able to train. Right. So researchers, they started working in 1958. And first, probably if I talk about any kind of neural network, right, they specifically was focusing on working on multi-layered neural network, right? Multi-layered neural network. And first neural network, if I probably talk about, is something called as Perceptron. Right, and today we will be discussing about Perceptron in depth. We'll try to understand what exactly is Perceptron and all. Right, but the main aim of deep learning, suppose if I consider this as deep learning, the main aim of deep learning is basically to mimic human brain. Okay, so this main aim is basically to mimic. Basically means like how we human being learn things, right? We also want to make sure that the machine also learns in that particular way. So here you can basically say mimic the human brain. Right, so mimicking the human brain is the most important thing in this specific thing, right? So here you're specifically mimicking the human brain, and we are making sure that the machine learning algorithms also learn in that particular way, or any machine also learns in that specific way, right? So this is an idea about deep learning, and our entire focus will be on deep learning for this entire 5 days, where we'll be learning multiple things and all, right? So what are things we will be specifically learning in deep learning? I'll just tell you in another 5 minutes, and by that you'll be able to get an entire idea about it. Now, one very important thing, where does data science fall into this, right? Where does DS, that is data science, fall? Suppose if I say data science can be the part of everything, so it can be the part of everything over here, right? It can basically, like, if you are a data scientist, you probably have to work on machine learning algorithms. You have to work, probably you may get a work to work as a data analyst, right? You may also work as a deep learning developer. But at the end of the day, the goal is to create an AI application. Okay, the goal, the last goal, the final goal is basically to create an AI application. So I hope everybody is able to understand. Can I get a quick yes till here? Right, so this was the first section. Quickly I wanted to cover it. So I hope you are able to understand till here. Can I get a quick yes? I'll just wait for your chat. Just let me know if you're able to understand. If you're able to understand, hit like. That will actually help me to get more energy. And let's go to the second part, where we'll be focusing on understanding different things. Right? So can I get a quick yes? You are able to understand everything over here? Yeah. So one very common question that we usually get, where does computer vision come into existence? It can be a part of deep learning also. We can also use computer vision in machine learning also. And we can use all these things, but at the end of the day, we are basically creating an AI application. But here I really wanted to talk about the major chunk that we are basically discussing, that is popular throughout the entire world. Whenever people talk about AI, ML, DL, or data science, we basically focus on to this, right? Now, perfect, everybody's able to understand. Now we will ask a very common question. Okay, the common question will be that why deep learning is becoming so popular. It is becoming so popular. It is even becoming popular more than machine learning. Why deep learning is becoming popular? right? Why deep learning is becoming popular? Now, this is the question that we will try to answer. Why deep learning is becoming popular? And I hope everybody has basically already told some of the points, and we had already discussed before. So the one major point why deep learning is basically becoming popular. So here I'm just saying why, right? The first point, obviously, right? Let's go back to 2005, right? 2005, which was the amazing social media network that actually came up. Before 2005, only Orkut was there in the market, right? Then later on, what happened? Facebook came, right? Now, Facebook is entirely based on Web 2.0. What is Web 2.0? It is a kind of the web application is developed in such a way that you'll be able to log in, you'll be able to store your data, you'll be able to interact with other people. So this Facebook was a social media networking website, right? You can put images and all. Later on, Instagram, WhatsApp, LinkedIn, Twitter, right? Instagram, WhatsApp, right? LinkedIn, Twitter, right? This all websites, this all web application had actually come, right? Now, in this all web application, what was the main thing? Like here, you are interacting with people, you are posting something. Now, because of this, the data started to get generated exponentially, right? Exponentially. Huge amount of data was actually getting generated, right? Exponentially, it was increasing. The size of the data was definitely increasing, right? So at that point of time, when I talk about 2008, the concept of big data, big data was in very high demand, because they wanted to store that data efficiently. They wanted to store this data efficiently. So that is the reason why big data team, basically big data engineering skill, became very famous at that point of time. People were looking for, like, when I was doing my engineering, somewhere in 2010 and 11, there was huge opening of big data, and big data are the people who are actually storing this information efficiently, so that we can actually read that particular data and use it wherever we require, right? So that is why big data became very, really, really popular. Now, as we went with time, probably in 2013, let's say 2013, as we went in time, now what things were happening? Company had huge amount of data, right? So company had huge amount of data, right? Huge amount of data. Now, if company has huge amount of data, will they just store and keep it? Will they just store and keep it, right? The answer is no. Right? The answer is no. They really want to use this data and basically bring a seamless experience into their products, right? They want to bring a seamless experience. They want to make their product better. And how that is basically possible? That is only possible when you utilize the data that is already available. So because of that, what happened? Since we had a huge data science, AI, I'll just write AI. AI started becoming very, very popular. AI became popular. Do you know when did I start learning AI? It was in the year 2013 to 14, right? So at this point of time, I made a successful career transition. And at that point of time only, I started learning. And I knew that in the future, this really has a good scope, in short, because data is getting generated from everywhere. Companies have petabytes of data, and every day it is going to increase, and probably in the future it is going to increase again exponentially. So definitely, in order for the company to make their products better, they really want to utilize this specific data and make the products still much more better itself. And best example, you can basically talk about Netflix, right? Netflix is using whatever data we have basically used in their app, right, while seeing movies, our profile information and all, and based on that they are recommending things, right? So that is why that is so important, right, with respect to the data, right? So data really has a amazing importance altogether. Let's talk about one of my company experience, that is Panasonic. So what is Panasonic famous for? Panasonic has lot of products, right? And what are this kind of products? Let's say ACs, right? Or TVs, refrigerators, right? And initially also, this all products, right, they were definitely generating data. And when I joined Panasonic somewhere around 2-3 years back, I got a chance to make these products quite smarter. right? Suppose I was specifically working with ACs. What did I do? I created a model, I created a model which can reduce the electricity bill, which can reduce the electricity bill, right? Because people, how they use the AC, they bump up sometime in the higher temperature, they come down directly to some lower temperature and all based on the outside temperature. What if I showed them a model that, okay, use this kind of profile, and based on the outside temperature you will be able to efficiently handle the ACs, and probably your electricity bill may get reduced, right? So this is one example. Now because of this, what happens is that they actually provide some seamless experience to their client. And definitely, when you come up with this kind of model, this can also be sold in subscription basis, right? Subscription basis. So through this, at the end of the day, since they are bringing seamless experience in their product, so what will happen is that the company will generate revenues. They will generate revenues. They will be able to make better decisions, right? They will be able to make better decisions. Perfect. So I hope you are able to understand the importance of the data. And this is with respect to the first point, right? All these things that I explained, why deep learning is becoming popular, because now you have a huge amount of data. Now let's go to the second point, right? Second point, which is super, again, very important, right? And that is hardware advancement, right? Hardware advancement. I hope everybody knows about NVIDIA, right? I hope everybody knows about NVIDIA. What is so special about NVIDIA? They come up with this amazing GPUs, right? What is GPUs? Graphic processing units, right? And you know that in deep learning, whenever you create a multi-layered neural network, many parameters are actually created, right? And when many parameters are actually created, you have to probably do the training in the in epochs, right? Multiple epochs, and probably for that, a lot of times will be basically taking place, right? So GPUs actually helps you to train your model very faster. And right now the GPUs are training the models. I'll specifically write training the models. It will be very, very handy, Now, recently, like if I talk about GPUs, this GPU's cost is really reducing day by day. And that is all because of the technological advancement. The before GPUs, like let's say an example of RTX Titan. Okay, so this was one GPU which I had on the first instance when NVIDIA had actually gifted me this. But today I'm actually using RTX 3090, which is more efficient than Titan RTX, right? So all these GPUs people are actually using. NVIDIA is doing more better jobs. They're coming up with their own libraries so that we can basically train our deep learning models in an efficient way, right? So I hope the another interview question everybody's clear about why deep learning is becoming very popular, right? So till here, if you have understood, you can just write down a comment section. You can give a heart symbol, anything as such, so that I believe that you have understood about it, right? So yes, if you're liking the session, also make sure that hit like and also subscribe, right? So till here, can I get a quick yes if you have understood? Okay, now let's talk about the next thing. Let's talk about the first thing, which is called as Perceptron. Now let's talk about Perceptron. Now let's go to the next point, which is called as Perceptron. And this is where I will first of all discuss about single layer multi-layered single layered neural network, and then we will probably discuss about multi-layered neural network, right? Perfect. Many people are liking the session. I'm very much happy with it. Hit do like, make it 1,000 anyhow. Okay, that would be amazing. Share with all your friends. Okay. Now, single layer neural network. Now, what happens basically in the single layer neural network? I'll just take an example of Perceptron. Okay, very simple. Now, if I consider, okay, what is the basic structure of this multi-layered or single layer neural network or this Perceptron? Let's say. Now, suppose I will be drawing some circles. The circles are not some food item, okay? So I'm just trying to draw the circles. Let's say I'll draw one more circle over here and I'll draw one more circle over here, okay? Now, I'll also be covering NLP, so don't worry. So this are my input Okay, so this we basically say it as input layers. Okay, this, since I'm creating a single layer neural network, so this becomes my hidden layer 1. So this becomes my hidden layer 1. Okay, and finally this becomes my output layer. Okay, this becomes my output layer. Now always remember, and let's do one thing. Let's connect this every dots. Okay, let's connect this every dots, and I will try to show you with respect to a good example with respect to our brain. Okay, so finally I get my output over here. Okay, now let's take one very good example. Okay, let's say I have a data set which shows whether the student has passed or not. Okay, suppose the student studies for play, and this will basically be my pass. Sleep, and this will be my play. Sorry, pass or fail. Pass or fail. Okay, let's say that I have this specific data set. Okay, let's say in one of the student has a record which is called as, he basically studies for 7 hours, he plays for 3 hours, he sleeps for 7 hours. So probably if he's studying for this many hours, I can say that the person will pass. And since this is a binary classification, I'm just going to make it as 1. Okay, then let's say second record is that if the student study for 2 hours, he plays for 5 hours, he sleep for 8 hours, most of the chance is that the student will fail. Okay, the third record, if I consider, suppose let's say the student studies for 4 hours, he plays for 3 hours, he sleeps for 7 hours, I'm going to make it as pass. Okay, let's say like this, I have so many records available with me. Okay, now with respect to this neural network, how will I basically use this data set to train this binary classification? Because this is a binary classification problem. Okay, binary classification problem. Let's see this. Okay, so I hope everybody is able to see this binary classification problem. Now always understand, this is my input layer. Okay, now in this input layer, this inputs will get passed. Okay, this inputs record by record, it will get passed. So the first input is nothing but study. Okay, I can basically say it as x1. Then the second input is basically play, I can basically say x2. And this third input is nothing but sleep, I can basically say x3. Okay, here you can basically see that. Okay, fine, x1, x2, x3 is my inputs. Okay, inputs, I will be passing this records. Okay, I will be passing this records. Okay, so here what I'm doing, every record will get passed at one time. Suppose in the first instance I pass 7, 3, 7, right? Because that is what is my first record basically saying. Okay, now let's say I have my eyes, right? And my brain is there. Now what is this input? Now I'm able to see this monitor, I'm able to see the camera, right? So this signal that is basically passing, that is an input, right? Now when I see this, right, when I'm seeing this, I'm able to determine, okay, this is the camera and I'm seeing to the camera, right? I'm seeing definitely to the camera, I'm seeing you all, right? So let's say hi to me, right? I'm seeing to you, I'm seeing you all through this virtual world, right? And definitely many people are able also to see me. If I close this camera, then obviously you will not be able to see me, or I'll not be able to see you. But when I see this camera, I'm able to determine, okay, this is the camera, and for seeing to the camera, I have to see over here. How this is happening? This input is passing through my eyes. This neural network, the signal goes to the neural network, and this is my hidden layer. This is my hidden layer neurons. So here I specifically talk about neurons. So this we basically say that, okay, this hidden layer has one neuron. And what is this neuron? Neuron, biological neuron. Everybody is familiar with that, right? Neuron does some kind of signal processing, right? It does some kind of signal processing. Now, since I'm seeing this camera, obviously through the input layer, so my eyes becomes my input layer. When it goes to the next neurons, those neurons pre-process that data. And then finally it comes to my output layer. Output layer is nothing but it is my brain somewhere in the backend side, which is responsible for seeing or visualizing the camera, right? So this, let's consider this is my another neuron. This is my output neuron, which will basically be able to predict what this is, whether it is a camera, whether it is a television, whether it is a mobile phone, or whatever it is, right? So this is what is the importance of this. So this specifically is called as output neuron. Okay, and this is responsible for planning your final output, how it will look like. But let's consider a baby. When a baby is born, right, if he sees the camera for the first time, will he be able to predict that this is a camera? The answer is no, right? Obviously, he needs to train, right? We need to tell him that, okay, this is a camera, this is food, this is your bed, this is milk, like that, right? We have to tell him, we have to continuously train him. Then after a couple of months, right? After a couple of months, he'll be able to understand. As soon as he sees a bottle of milk, he will start crying, right? That usually happens with my son. So my son is somewhere around 7 months. Now he understands what is a mobile phone. He understands how does his milk look like, in a bottle. So all these things he's basically be able to understand, because from the day one he's getting trained, right? He's getting trained on that specific thing. So whenever we create a neural network from scratch, right, always we need to train them, right? We need to train them based on the outputs. This is the output, right? This is what is the output we have to train based on this input data. Suppose if I show the mobile phone, it should be able to predict, okay, this is a mobile phone, right? We have to train them, right? Suppose if there is a camera, and if I see the camera, I have to train that, okay, this is the camera itself, right? So the training process is something different, right? But I hope everybody is able to understand what does the hidden layer 1 look like and what is output layer. And like this, we may have any number of hidden layers, because the signal passes through various neurons, one neuron to the other neuron, and each and every neurons will be having a different hidden layer. In the hidden layer 1, I may have 5 to 10 neurons. In the next layer, I may have 100 neurons, right? And each and every neuron will be processing those signals that is given from the input layer. So is this clear till here, everybody? So recently my child also said Papa, right? So I had to train him for 6 months. I had to tell him daily Papa, 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 Papa. Then finally he was able to talk about it, right? So that is the most happiest part. I have trained a original human neural network. So that's amazing, right? So that is the reason why I'm able to explain you with so much of in-depth analysis, right? So I hope everybody is able to understand over here. Yes, can I get a quick yes? If you are able to understand, please do hit a like, and I hope I'm able to cover everything that you are actually wanting. Now we'll understand what kind of processing will happen in the next section. Okay, fine. I have understood this is my input layer, this is my hidden layer, this is my output layer. But what is the processing that actually happens, right? What is the processing? What is this line for? When the signal is getting passed from here to here, when the signal is getting passed from here to here, when the signal is getting passed here to here, what is the thing that will happen inside this neuron that we can basically see? Okay. So I hope everybody's clear till here. Let's go to the next step, and I'll still not again create all these things. So I will just do a little bit of smart work, and I'll copy the same thing, copy it, and I will paste it over here. Amazing, right? So I love this editor, So how do you like to rate my handwriting, guys? Is it good or not? Is it good? Yes. Yes, we are training in the hidden layer neurons, right? Now, how the training will happen, we'll discuss about it, okay? How the training will happen. Now, let's go, okay? I've already shown my data set. My data set looks like this, okay? 7, 3, 7, 1, like this. So input will definitely go. Now, what will happen when the input passes to the hidden layer 1? Okay, what happens, okay? What happens when the input from the input layer, it goes to the hidden layer 1? Now it is very much important, okay? Over here, we assign some weights. Oops, just a second, guys. I think, okay. Let's see. Now what happens, okay? No, it is not necessary you need to have hidden layer 1 only, okay? You can have many hidden layers. I'm just talking about Perceptron. This is one example, okay? Now, let's say what happens in this layer, what happens in between as soon as the input goes to the hidden layer 1. So here we assign weights. Let's say these are my weights, okay? Now, what is the importance of this particular weight? We will try to understand. But before that, what do we do with this weights? We'll try to understand. Okay. And let me do one thing. Okay. Let's understand what happens since this weights is there. What happens inside this neuron? So I'm going to take this neuron. I'm going to just make a bigger structure so that you'll be able to understand. So this is my neuron. Okay. In this neuron, oops, what happened? Something happened. Oops, just a second, guys. Something happened. I will do it. Wait. I will just again. Let me create it. Okay. Let me create it once again for you all. I can take this much pain. Come on. So this is my input layer. Input 1, input 2, input 3. All right. And let's say in my hidden layer this time I take 2 neurons. So 1, 2 neurons. Let's say I can have any number of neurons. Okay. I'll talk about how the weights is decided and all. Don't worry. Okay. And finally, this is my output layer. Let's connect this quickly. So this is my I1, input 1, input 2, input 3. And this is getting connected over here, here, here. Remember, every neurons will get connected, right? Every neuron has to get connected, so then only it will be working, because it is just like our brain cells, right? Every signal will get passed. Okay. Now, let's talk about it. So this is my X1, this is my X2, this is my X3. Now what happens inside this? Let's talk about it. Like what exactly happens in this? So here I will be assigning different weights. Okay, I will be assigning different weights. So let me just make this diagram a little bit more simpler, so that again you should not get confused, because if we are able to understand one, right, then definitely you'll be able to understand all the other things. Okay. So what I'm going to do, I'm just going to take one neuron, and I'll make this neuron size bigger so that 2 operations can fit in this. And finally, my output neuron. Okay. So this will get connected over here. This will get connected over here, and this will get connected over here, and this will get connected over here. And finally, this is my output. So this is my hidden layer 1. This is my output layer. Okay. So I hope everybody now, here I've already told you we will assign different weights. I'll talk about the importance of weights. Now inside this, there will be 2 operations that will be happening. The first operation will be that we just have to do the summation of x of I and w of I. Okay. So what we are doing, summation of x of I, w of I, that this basically means what? If I write the equation, what is summation of x of I, w of I? It is nothing but x1 w1 plus x2 w2 plus x3 w3 plus. Okay. So here what we are actually doing, we are just multiplying x1 and w1 plus x2 and w2 and x3 and w3, right? I can also write this as w transpose x. Okay. And I hope everybody remembers this thing, right? It is similar to our equation of the linear regression, like beta 0 plus beta 1 multiplied by x, right? We can also write this as beta transpose x, right? Same linear regression. If you remember, in linear regression, we also use y is equal to mx plus c. Different equations, right? So same thing, right? So this is nothing but w transpose x. Okay. So w transpose x is nothing but it is the summation of x1, it is a summation of inputs multiplied by the weights. Okay, input multiplied by the weights. So this is the first step. This is the first step in the signal. Okay, and this is basically the first step. Now what about the second step? In the second step, we pass this equation to an activation function. We pass this to an activation function. Okay. So we pass this to an activation function. Okay. Now let me first of all, okay, before going to the second step, let's understand what is the importance of this weights. Okay. Now tell me guys, suppose if I put a hot object in my right hand, then will I not move my right hand away? It's a very common question. See, very simple question. What I'm doing is that I will put a hot object into my right hand, and then obviously it is sure that I will be removing my right hand. Okay, I'll be removing my right hand. Now, when I remove the right hand, the reason why I'm removing the right hand, because the neurons that are passing from here, those are getting activated, right? Those are getting activated, right? If I'm putting a hot object over here, the neurons will definitely pass that signal to the brain saying that something hot object is placed and I'm going to move it. So these weights will actually help your neurons to act, whether it should be activated or what level it should be activated. Let's say if I'm putting the hot object into my hand, I'm not moving my left hand. That basically means my neuron are signaling the weights over here, and it is making sure that all these neurons get activated till it passes the signal. So this is the importance of weights. During the training of the neural network also, we will be taking care that which weights should have what value so that the neuron should be activated till that level or not. Okay, very, very simple. This is the most easiest way to understand about weights. Okay, so weights basically says that how much the neuron should get activated or deactivated. That's it. Very simple if you really want to understand as a person who really want to clear the job interview quick as possible. Okay, now I hope everybody has understood this. Okay, now what if, see, this weights also initially we initialize it as 0. Okay, we initialize it as 0, right? Let's say that I have initialized it to 0. It is not necessary that we always initialize to 0, but let's say I have initialized to 0. Now, if I have initialized to 0, what will happen? X1 multiplied by 0 will be 0, X2 multiplied by 0 will be 0, X3 multiplied by W3 will also be 0. Okay, now when all these values are 0, we are just passing 0, right? So for that to overcome, so that the weight should not be 0, we add another parameter, one more parameter, which is called as bias. Okay, so I hope everybody is understood why do we add a bias, and I hope you have seen this term, right? This is a constant term. We basically say it as a constant. We basically say that it is an intercept, right? Intercept, right? We say C as intercept, right? So that is the reason why in that equation also you'll find an intercept. In this also you have a bias such that by mistake, if you probably initialize all the weights as 0, bias will have some value, so that some value it will not be equal to 0. So we can continue that particular training. Later on we can update the weights, right? So I hope everybody is able to understand. Can I get a quick yes? We are going very slowly. We are understanding each and everything. I hope you're loving the session. Just let me know whether you're liking it or not. So I'll just wait for everybody's answer, and then again I'll continue. Yeah. Tausif, bias initialization will automatically happen by the neural network. We'll see basically in the practical session and all. Okay. Suppose if my weights is becoming 0, if I've initialized it to 0, there will be some bias value, right? Okay. Perfect. Now, what happens in the second step? Let's understand. Okay. What happens in the second step? Okay. So in the second step, let's say that this entire equation that I have written, that is summation of x of I, w of y is given by y. Okay. Then we pass an activation function on top of y. Okay. An activation function on top of y. Okay. Now, yeah, bias will be required in every hidden layer. Okay, every hidden layer it will be required. One bias will basically required. Now, what is this activation function? Let's say again, I put a hot object in my hand. I'm moving the hand, right? I'm moving the hand. So this basically shows that whether the neuron should be activated or deactivated, right? So one example of the activation function, which I'm going to basically take, is something called as sigmoid activation function. Now, this sigmoid activation function, what it does is that I will talk about the equation. It is 1 e to the power of minus y, let's say. Okay. Now, We will discuss about ReLU and all on the other in the upcoming classes. But let's say one example of this. This is a sigmoid activation function. We basically use it for binary classification. Let's say binary classification. Okay. Now, if I replace y, now y is what? This one, right? 1 plus e to the power of minus this summation of x of y, w of I, right? Plus bias. Sorry, I have to add bias also on top of it. Okay. I have to add bias also on top of it because this bias is also getting added right over here. Now this entire thing will become summation of x of I, w of I plus bias. Okay. B. Okay. Now the output of this equation is either 0 or 1. That is what sigmoid activation function does about. Sigmoid activation function always gives the output as 0 or 1. It is not like it always gives 0 or 1. It can give you values between 0 to 1. We write a condition if it is greater than 0.5, we basically take it as 1. Greater than or equal to 0.5, we take it as 1. And if it is less than 0.5, we take it as 0. Okay, so this two condition usually applies in sigmoid activation function. But the main reason of the sigmoid activation function is to basically say that whether this neuron is activated or not. Okay. So I hope everybody is able to understand. And this usually happens in every neuron. Okay. First thing, summation of the weights and the inputs along with the bias. So here I'm going to write plus bias, and then this will be an activation function of y. Okay. On top of it, we take this entire thing and we put up a activation function. Okay. So this is what happens. And then when we go to the next layer, another weight will get initialized over here. Again, two steps will basically happen. That will be the summation of this output, whatever output I'm getting over here. Let's say O1. Okay. O1. And this will get multiplied to W4. Again, what will happen over here? The next activation function will get applied. And finally, I'll be able to get 0 or 1. Okay. Everybody clear? Yes. Yes. Everyone. Sigmoid is not only the activation function, we have various different types of activation functions, which we are going to learn till tomorrow. Okay, so don't worry, we will talk about it. Now, this is with respect to binary classification, we use sigmoid activation function. For linear regression, what all things we use? There is another activation function, which is called as linear activation function. This also thing we'll discuss. Today, I just want to introduce you to some basic topics, and that name should be always there. So what all things we have learned till now? We have learned topics like what is weights, right? We have learned topics like what is neurons, right? We have learned about neurons. We have learned about hidden layers. We have learned about we have got an idea. We have got an idea about this terminology. What is activation functions, right? So all these things, slowly now we are going to cover more and more topics, okay? But today, I just want to show you what all topics are basically there. What all topics are basically there. Okay, everybody is able to understand, right? So I hope everybody was able to understand till here. Let's continue the next topic. Now I will give you an idea about forward propagation. Now, whatever operation that we have done till here, from here to here till the output, right? What all functions we did? We basically took the input, multiplied by the weights, added a bias and activate, right? We multiplied the inputs with the weights, added a bias and activate, right? So this you can basically remember. We took an input, we multiplied with the weights, we added a bias and then we activated, right? So this entire process till the end is called as forward propagation. So this is basically called as forward propagation. Okay. So this is basically called as forward propagation. Now, let's discuss one very important thing. Okay, let's discuss one very important thing. Let's say for this first input, okay, this first input, 737 I passed, I went inside this, I initialized a weight, and let's say I got an output of, let's say I got an output of 0. Okay, I got an output of 0. Now, when I got an output of 0, okay, when I got an output of 0, but this 0 will be my predicted value, y hat. This will be my predicted value, that is y hat. Okay, for the forward propagation, first forward propagation. Then what is my y? Y is my truth value. So what is my truth value over here? My truth value is 1. Right? My truth value is 1. I hope everybody is able to understand what is my truth value. Here, obviously my truth value is 1. So if I take this 0 and 1, if I just subtract it, y minus y hat, obviously this is not the output that I want. I want 1 as my output, but I am getting 0 as my output, right? So if I subtract y minus y hat, I'm actually going to get 1. Yes or no? Yes, everybody's clear? See, y is nothing but 1, y hat is 0. 1 minus 0 is 1, right? 1 minus 0 is 1. Yes or no? Okay. Now, since my difference is 1 and I know my output is completely wrong that I'm getting, right? So, what I have to make sure that this difference should be very near to 0. Okay. This difference should be very near to 0. So what can I do for that? And what is this y minus y hat? There is a very important term which is called as loss function. So what is loss function? Loss function, they are different kind of loss function. Okay, there are different kind of loss function which I'll be discussing. But here I'm more focused to tell you about terminologies. So loss function will basically find out the difference between your predicted value and your real value. And always the main aim should be that we should try to minimize the difference. Everybody clear? We should try to minimize the difference. The difference should be very much near to 0. Then only this y hat and y will be matching, right? So this is basically called as loss function. Okay? This is basically called as loss function. Now, I know my difference is quite huge. Now, what is the next thing that I have to do if my difference is huge? We then do a very important thing which is called as back propagation. And what is the aim of the back propagation? The main aim of the back propagation is to update, update weights. Because only when I update these weights, right? Only while we are updating these weights, right? Then only we will be able to get this predicted output matched to our real output. What is my real output over here? I'm training a supervised machine learning or deep learning problem statement. My output should be 1, but I am actually getting 0, right? So to reduce this difference, what we have to do is that we have to update these weights, right? We have to update these weights, and this updation process will basically happen because of back propagation. And how is this basically happening? How back propagation is happening? So we have another concept which is called as optimizers. These optimizers will make sure that each and every weight will get updated while we are back propagating. So guys, are you able to understand or not? Understand the process. Don't worry about what is happening inside. That I will definitely cover. The maths part, I will definitely cover. But understand how the training happens. This is the training process. Training process includes weights, it includes forward propagation, it includes bias, it includes this operation that is happening inside the neurons. And then when we get the output, we find out the loss function, right? And what is the difference between the loss function? If the difference is high, then we back propagate it and we update the weights with the help of back propagation. And over there, we use something called as optimizers. How many of you know simple linear regression? How many of you know simple linear regression? How many of you know simple linear regression? Tell me. Okay. How many of you know simple linear regression? Just tell me. In simple linear regression, have you heard of gradient descent? So one example of an optimizer is gradient descent. What is gradient descent doing over there? It is changing the coefficients. Yes, it is a combination of both forward and backward propagation. In the backward propagation, weights will get updated. In the forward propagation, weights multiplied by the inputs, bias will get added and an activation function will get added till the output is basically coming. Right? So in simple linear regression, I hope everybody has heard about gradient descent. Right? Gradient descent. What is this gradient descent? What it does is that, I hope everybody has seen this curve, right? Seen this curve, right? Gradient descent will make sure that the coefficient, this is the coefficient, right? This will be the coefficient. It will make sure that it will update this coefficient from here or here to basically come to the global minima. And this global minima, the difference of y and y hat will be minimal. And the same thing is basically happening in this thing also. So that is the reason when I explained about machine learning, whether you have seen or not, I have explained this specific thing. And this gradient descent is a kind of optimizer. This is a kind of optimizers. I hope now you are getting an idea, everyone. Yes. For the people who are not getting an idea, just go through this video once again. Everything will make sense. Okay, everything will make sense. So in short, let's start the story. Whatever things we have learned from today. So story conclusions, I'll say. So first step, what is this? First step, we have learned about input layer. Now from the input, where it goes to the second step, weights will get added. Right? The third step, after the weights, the input and the weights will get added, and then it will get added along with the bias. And then what is the fourth step? An activation function will get applied. Activation function will get applied till the last layer. This entire process in the forward propagation. Forward propagation. Right? And in the backward propagation, what will happen? Fifth step, in the backward propagation, first we calculate the loss function. Loss function is nothing but the difference between y hat and y. Let's take this one example, the different types of loss function. We have to minimize this value. How do we minimize? We use optimizers. Optimizers, what it does? It updates the weight. Updates the weight. And this is the entire process of what? Backward propagation. Backward propagation. And if this step is happening one forward propagation, one backward, if we are doing it 1,000 times, our neural network will get trained just like a baby gets trained. That's it. That's it. That's how important it is and how easy it is. If you are able to basically see it with examples. Right? You are able to understand this. Right? So it is just the combination of forward and backward propagation. And here you will be able to get some amazing outputs. Like this, let it be image classification, object detection. Now, what all things in deep learning will be there? Very much important. One thing, you'll learn about ANN. You'll learn about CNN. You'll learn about RNN. Everything works on forward propagation and backward propagation. You learn about object detection. Object detection. Everything works on forward and backward propagation with different optimizers. Right? And we don't have to even do 1,000 times. Within 10 times also, if the neural network is able to train, it is able to train, right? Okay, let's take one example. I've shown you a new kind of species. Let's say I've shown you a new kind of flower. Suppose you don't know the flower name. Okay, today I will train you. Okay, this flower is black rose, let's say. Okay, so you will just remember, okay, he told black rose. Tomorrow I may show you again that particular flower. Then you may again not be able to remember. If tomorrow also I say you that, okay, this is black rose. Then second day, okay, you'll get more confident. On the third or the fourth day, whenever I show you that particular flower, you will be saying that it is a black rose. And that is how we train a neural network like we train a human beings. Okay? Now, let's understand how does a multi-layer neural network look. That was a single layer neural network, right? A multi-layer neural network will have a lot of inputs. Let's say I have inputs over here. In the hidden layer, I will be having so many different neurons, right? Over here again, I may have any number of neurons, not limited to anything. And here in the output layer also, I may have multi-class classification problem. Okay, and this all will be combined together. Let's say I'm going to use green dots. This all will be combined together, right? This all will be combined together, and this is nothing but a multi-layer neural network, and it is going to basically just do the same process whatever I've taught you in the single layer. Nothing different. In every layer, bias will get added. Everything is almost same. Everything, nothing. I've not hidden anything, any concept with you now. Everything will get connected and everything will there. Just for case of multi-classification, a different types of activation function may get used, a different kind of loss function may get used. That's it. Okay, so this exactly is called as a multi-layered neural network. It need not be only 2 hidden layers, any number of hidden layers. So multi-layered neural network. And finally, this is my output. Okay, so this is my output layer, this is my hidden layer 2, this is my hidden layer 1, this is my input layer. That's it. So how confident now you are? If you really want to make a child understand, tell me how confident you are now. Are you loving the explanation? And just imagine, in 1 hour, we have covered so many things. If you know this much for the interview also, then also you'll be able to crack the job with some practical implementation. Because they will not go inside that how mathematical equation will be there in optimize and all. That just for our learning interest, we learn those things. Right? How to know how many hidden layers? We'll discuss about that. Don't worry. Okay. Sir, why is there a need of neural network? Very nice question. Anybody wants to answer? So see how many pages we have covered in a better way. So my handwriting is fine, guys. Yeah. So I think this is too much of knowledge, right? Now what we will do is that tomorrow we will understand about in-depth activation functions. What are the different types of activation function? We'll also be understanding loss function. So tomorrow I'll try to cover this too. How to update the weight and optimizers will be covered in day 3. And in day 2, in day 3 we'll also see practical examples. Okay. And those practical examples will be super important because by that you will be able to learn ANN anyhow that you want. Okay. The editor that I'm actually using is something called as Scribble Ink. It is present in Microsoft Store. It is hardly for 300 rupees. And obviously my handwriting is my handwriting. Okay. Okay. My handwriting is my handwriting. So why there is a need of neural network? It is basically to mimic the human brain, how a human brain basically gets trained. We also want to train our neural network like that. Okay. Our machine learning applications or any applications like that. Okay. Okay. Perfect. Now, okay, there is also one concept in back propagation. You know, there is something called as derivative or chain rule of differentiation. So that thing also tomorrow I'll cover. Chain rule of differentiation. Okay. Chain rule of differentiation. We'll also cover this. So I hope you have understood this video. Again, all these materials do you require it, guys? ANN, see what all things we are going to learn. First of all, we are going to learn ANN. Okay. Already we have started. This Perceptron is a concept of ANN. Then we'll go with CNN. Then we'll go with RNN. And then probably we will try to close some example of object detection. But I need another 7 days to complete NLP. Okay. NLP introduction will be done over here. Okay. But NLP completely in depth, I will take another 7 days to complete it. Okay. So that we will plan it probably in this month or in next month. Okay. So okay. Okay. Make sure that all these materials that I'm actually going to give will be in the dashboard link that is given in the description. So please go over there and try to enroll it. It is completely for free. And I will provide you this material also, whatever I have written. It looks quite amazing. See, this is one of the session that I had taken the deep learning, and this is how the material looks like. So do you like this material? See this? Okay. So this is how the materials look like. See, so if you probably try to see this, similar kind of materials will be getting in the PDF format. Okay. Yes. So we'll also cover LSTM within this 5 days. Okay. Okay. Okay, guys. So I hope you like this session. Can I get a quick yes if you have liked it, if you have loved it? Today I'm just keeping it to 1 hour 15 minutes so that you digest all these things. And tomorrow I will be covering most important maths part uh, and all. So that will give you a tremendous amount of knowledge. But trust me, if you know this much, you will be able to crack any interviews. Okay, any interviews in an amazing way. Okay. Okay, guys. So okay, this was it. Please make sure that you hit like, uh, subscribe my channel, and I want to request everyone, guys. Please make sure that you share it in all the platforms like LinkedIn and all. I really want the audience to be 1,000, 2,000 over here, because these are some important things which is completely for free, right? You will be able to learn it. You will be able to interact with people over here. So please tell me whether you will be sharing this session or sharing tomorrow's session with everyone or not. Please do let me know. Okay, and we will be learning in this way. It is up to you. If I have come up to build the community session, I really want to build the community session in a proper way so that everybody understand the importance of this. Okay, and this will be very much important for others, so please make sure that you do that, and also make sure you subscribe my Hindi channel. So how many of you also know that I have started uploading data science in Hindi also? How many of you know that? How many of you know that I have also started uploading videos of data science in Hindi also? Check out the Krishnaik Hindi channel. Just go and search for it. Okay. And yes, that's it. I will also give the link to you all. So please subscribe the Hindi channel so that there also you can check out for the people who are comfortable with Hindi. And probably I'll also be coming up with other languages like Kannada, because I know also Kannada and all. So definitely please make sure that you check out. And this is my Hindi channel. Everybody, I'm just pinning it over here. I pinned the message, so everybody go ahead and subscribe it. This was it. And yeah, I will see you all in the next session. Till then, have a great day ahead and keep on rocking. If you like my videos, please make sure that you share it everywhere. LinkedIn, this 5 day session will be very much important, where many people will be able to learn it. Okay. So that's it from my side. And yes, keep on rocking, keep on learning. I will see you all in the next session. Have a great day. Thank you, one doll. Bye-bye. Okay. And yes, about the books, I do refer this book. Let me show you the book that I refer. This is the book that I refer. Okay. Apart from this, I also have one more book. So these 2 books I usually refer. Okay. So I've already completed anyhow these 2 books, and probably will be covering many books as such. Okay. This is the plan. And yeah, please make sure that you share it everywhere. Okay. Thank you, everyone. Have a great day. Thank you. Bye-bye.